So, hey guys, welcome back again to my YouTube channel. So, for today's video, I will do a summary of Chapter 6. For Chapter 6, we have the network layer. So, network application and services. On the one end, the device can communicate with applications. So, um, network application and services on one end device can communicate with the application. So it means, for example, we have a end device laptop. It can communicate with application and services running with the other end device. So it means, so if we have a end device, it can communicate with application uh, with another laptop and device. So, how is this data communicated across the network in the efficient way? So, the protocol of the OSI model network layers specify addressing and process that enable transport layer data to package and transport. So, it can communicate across the network efficiently by enable transport layer data package to be transported with the application. So the network layer encapsulation they enable data to pass the destination within a network with a minimum overhead. So this chapter focuses on the role of network layer. Excuse me. It divides network into group of hosts to manage the flow of data packets within networks. So let's proceed. So we have network layer. So addressing end device. So end device must be configured with unique IP address for identification of the internet on the network. So just like what I said, for example, a laptop. So every end device has a IP, unique IP. So for example, so we have a PC. So for we have a PC and the unique IP address for one PC is 192.168.1 and that one. So that is the unique IP for PC. And then encapsulation, the network layer encapsulated protocol data unit PDU from the transport layer into the packet. The encapsulation process add the IP header information such as IP address of the source. So for the encapsulation, it can add the IP header information such as the IP address of the source. So routing, the network layer provides services to direct packets to the destination. So host on other network to travel to other network. So for the routing, it is travel to another network. It can provide a service direct packets to the destination host. So let's play this. So it is binary, then encapsulation, and then encapsulation, and it received with the other end device. So let's move on. So for network, we have a version, the IPv4 and the IPv6. Internet Protocol version 6, Internet Protocol version 4. So capsulating IP. So IP encapsulates the transport layer segment or other data by adding IP header. So this header is used to deliver the packet to the destination host. The IP header remains the same from the time the packet leaves the source host until it arrives the destination host. So here's the figure one. So shows the process to create the transport layer PDU. So is the create transport layer for PDU. And the figure 2 illustrates how the transport layer is then encapsulated by the network layer PDO to create an IP packet. So we have a transport layer encapsulation, we have segment header data, transport layer PDO. So network layer encapsulation, IP, we have a IP header data, network layer PDO, and IP packet. So characteristic of IP, IP was designed a protocol with a low overhead. It provides only functions that are necessary to deliver a packet from source to destination. So the characteristic of IP is to deliver a packet from source to the destination. So IP connectionless. So let's play. So the sender doesn't know if the receiver is present, if the letter arrived, if the receiver can read the letter. So the receiver doesn't know when it is coming. So we have a letter, mailbox, letter, figure 2. We have the here's another example of the connection, IP connection. We have IP in the segment. After we have encapsulate, and then so after that we have the encapsulate. So IP packet can travel over different media. So IP media independent, IP operates independently of media that carry the data lower layer of the protocol stack. As shown in the figure, IP packet can be communicated as electronic signal over copper cable, optic signal over fiber, or the wireless as radio. So we have um, copper cables, and then fiber, and then wireless radio signal. So it can carry data lower layer for the IP media independent. So we will not answer this. We have a IPv4 packet header. So we have version contains 4-bit binary value set. So for version we will it has a 4-bit and differentiated services or diffserv or DS formally called the type of service. So DS is a 8-bit field. So time to live TTL uh, contains 8 bits. So binary value. So you have to get the main word of different um, different meaning. I will not answer this. So limitation of IPv4, we have IP deflection. IP has limited number of unique public IPv4 addresses available. So for IPv4, it has a limited number of you will input an unique IP address. So internet routing table expansion or routing table is used by routers to make the best path determination. So uh, for it is the best thing that you could um, or the best path for destination is the router. So lack of end-to-end connectivity network address translation is technology commonly implemented within the IPv4 So we have default gateway for switch. So typically a work group switch that interconnect client computers in layer 2 device such as a layer 2 switch does not require an IP address. So layer 2 does not require an IP address. To function properly, however, if you wish to connect to the switch and administrative manage it over multiple network, you will need configure the SVI with an IP address. So default gateway is typically configured on all devices that wish to communicate beyond their local network. So default gateway is um, it can configure the all devices to communicate beyond the local network. So we have a example for the um, figure one. So configuration of default IP. So config terminal and the IP default gateway. We will not include that. So chapter 6 here, this is the end of the video for the summary of chapter 6. So the internet is largely based on the IPv4, which is still the most widely used network layer protocol. An IPv4 packet contains IP header in the payload. However, IPv4 has limited number of unique, just like what I said, it has a limited unique public IP address available. So hosts require local routing table and ensure the packet is directly correct destination network. So the local table of a host typically contains direct connection, the local route, and the local default route. So here's the summary of the chapter 6, and I hope you enjoy it, and thank you for watching. And after that, after this video, I will summary the chapter 7. So stay tuned, and bye. So here's the what do you call this, trivia. So for chapter 6, focuses on the IPv4 and IPv6. So you can uh, you can study the function of the IPv4 and IPv6, and then what is the bit and the addressing, just like that, and the default gateway and routing table for you to master the chapter 6. And thank you for watching.